Okay, so here we are. We're picking up where we left off on our chi-square test. You'll remember we had these tables, a table here of observed counts and expected counts that we computed from the observed counts. We used the marginal counts here on the table of observed counts to create our expected counts, but we don't need them any longer. So what I've done is I've transferred all the observed counts and the expected counts to these two smaller tables. These are the only numbers we need now. So now what we're going to do is we need to compute another table based on these two. And each cell here in this table is going to be contain a number that's calculated in the following way. We go to a cell, to two corresponding cells here, the 9 and the 9.92, and we use this formula to get the number over here. We take the observed value, which we'll call little o, minus the expected value, little e. We square that, and then we divide by the expected value, or expected count. So for this cell right here, what we would have in that case is that O minus E squared over E would be 9 minus 9.92, all that squared, divided by the expected value, which is the 9.92. And for reasons you'll see in a moment, we're going to round our results on these to 3 places past the decimal. So in this case, when I compute this and round it in that manner, the value we get is 0.085. So let me put that number in this cell. I'm going to leave the, well, let's put it all in there, 0.085. And that's the value in there. So again, we take the observed minus the expected, square it, and divide by E. So if we were moving on to this next cell, the observed is 18, so we take 18 minus the expected is 14.25. We square that, and we divide by the expected 14.25. So in that case, when we do that for this cell, the value we get is 0.987. So at this point, what I'll have you do is, why don't you go ahead and pause the video and compute either all the remaining cells in this table, or at least a couple of them yourself, to make sure that you're doing that correctly. And when you hit play again, then we'll pick up and fill those in and move on from there. So go ahead and pause now and do those computations. Okay, so let's go ahead and fill in the rest of the table now with values, hopefully the values you obtained. So here we have 0.440. In this cell, 1.049. Again, rounding to 3 places past the decimal. This one will be 0.139. This one will be 1.607. Here we have 0.719 and 1.708. Now there's no names for these values. These are just the observed minus expected squared over expected values here. And these are the values now that we're going to use to get something called the chi-square statistic. So to get the chi-square, and the chi-square is the same sort of thing as a z or a t, but it's what we use for this kind of situation where we're comparing groups with categorical data. To get the chi-square, we simply add up all of these values here. So when I add all those up, which you can easily do on your calculator, the value we get is 6.734. So again, this is analogous to a z or a t. In particular, you might want to think of the t from the t-test we just did. So now what we're going to have to do is use this value to get a p-value. But you'll remember when we were doing the the two-sample t-test, that we needed not only our t, but a degrees of freedom. So in this case, we need degrees of freedom as well. And the way we get our degrees of freedom when we're working with one of these two-way tables is like this. The degrees of freedom is the number of rows, which I'm going to signify by R. So you take the number of rows, in this case 2 rows. We don't count the rows where we had marginal counts, just the original counts. So we take the number of rows and subtract 1. We take the number of columns and subtract 1, and we multiply those two together. So rows minus 1 times columns minus 1. So here we have 2 rows. So we take 2 rows minus 1. We have 4 columns. So we take 4 columns minus 1. And so this gives us 1 times 3, or 3 for our degrees of freedom. So those are the two numbers we need now. We need our chi-square and we need our degrees of freedom, which are 3. So then we go to this table, which is the chi-square distribution table. And let me just write down right here, let's put in our chi-square so we can remember what it was. Our chi-square was 6.734. And our degrees of freedom was 3. So we use this table just like we used the table for the t distribution. We go down until we're in the row for our degrees of freedom, which is 3. And we go across and see where our chi-square fits. And our chi-square in this case fits right in here. And so that means our p-value is somewhere between 0.10 and 0.05. Right? And again, like we did with the t-test, what we want to know is how small our p-value is, and we know our p is less than 0.10, the larger of these two values. And that's what we're really after. P is less than 0.10. So that's our p-value, which tells us whether or not we would reject our null hypothesis. If we had, for example, a level of significance of 0.10, then we would reject the null hypothesis because our p is less than 0.10, which is the alpha. So in that case, the p would be less than alpha, and we would then reject our null hypothesis. In the event that the level of significance, which had been set ahead of time, if the level of significance would have been 0.05, then in this case we would not reject, because our p-value is not less than 0.101, or between less than 0.05. We know it's less than 0.10. So that's our conclusion in this case. Let's suppose that we had an alpha of 0.05. We would not reject our null hypothesis. Remember, our null hypothesis would be that there's no difference between the different majors of students that take Math 243 in how useful they feel the course will be for their major. So that would be our conclusion then in that case, where we did not reject the null hypothesis. So that concludes our chi-square test. Let's go through again just briefly the steps. So remember that we started out with this table here, and let me block the edges out on that. So we started out with these observed cell counts here. Okay, so that's what we have to begin with. And remember, the next thing we do is we total up each row to get our row sums. Over here, 44 and 27. We total each column to get the column sums. That's these values. We add up all the column sums or the row sums. Either way, we should get the same number to get our grand total of 71. Then we use those row sums and column sums and the grand total to compute these expected cell counts. And remember, the way we get an expected cell count is we go up to the previous table. So if we were looking for this at this cell, which corresponds to this spot, we take its row sum times its column sum, so 27 times 23, and then divide by the grand total, 71, which is where we get this number 8.75. So then at that point we have our observed counts and our expected counts. And then what we do with those, and again I've reproduced those two tables here. So we have the observed counts and the expected counts. And then what we do is we concoct these other numbers. We fill in another table based on these, where each cell is filled in. We take the observed count, like for instance this 5 right here, and we subtract the corresponding expected count, 8.75. So we take 5 minus 8.75. We square that and divide by the expected count, the 8.75. That's not what I did here. This is for this first cell. But we then take the result of that and we put those results for each of those computations in this table. We total all those values up, which gives us the chi-square statistic. That's the main thing we're after. We compute the degrees of freedom, which is the number of rows minus 1 times the number of columns minus 1. So in this case, 2 minus 1, 2 rows minus 1, and then 4 columns minus 1 is 3. So we get 1 times 3, or 3. And then we use the degrees of freedom and the chi-square value in this table to determine a p-value in the same way we did with the t-distribution. Once we have our p-value, if we know our level of significance, then we know whether or not we reject the null hypothesis, and we can reach a conclusion for whatever it is we're studying. So that concludes the how to do a chi-square test.